Exploring TCP/IP technology details. Dive deep into the blueprint of the Internet with our comprehensive guide on TCP/IP technology, where we unravel the complexities and innovations that keep the digital world connected. Alqubit, IT as an expression of art. Understanding the foundations of TCP/IP. TCP/IP, or Transmission Control Protocol/Internet Protocol, is the suite of communication protocols used to interconnect network devices on the Internet. The foundations of TCP/IP begin with its two core protocols, TCP, which ensures reliable transmission of data, and IP, which routes the data packets to their destination. The design of TCP/IP is inherently hierarchical and modular, allowing it to adapt to the multitude and variety of systems connected to the Internet. Understanding TCP/IP is crucial as it lays the groundwork for establishing connections, managing data flow, error detection, and recovery mechanisms. The protocol suite's ability to enable diverse systems to communicate despite differences in internal architectures has been a key factor in the widespread adoption and longevity of TCP/IP as the backbone of the Internet. Insight into TCP/IP packet architecture. Diving into the TCP/IP packet architecture reveals a structured approach to data transmission. Each IP packet encapsulates data and carries metadata necessary for routing and delivery, including source and destination IP addresses. TCP, on the other hand, ensures data integrity and orderly delivery. A TCP segment contains a sequence number, acknowledgement number, flags, window size, checksum, and urgent pointer, which all play roles in managing the state of the transmission, flow control, and congestion avoidance. Furthermore, the TCP headers options field allows for advanced features such as selective acknowledgements and window scaling, which are vital for optimizing communication over diverse network conditions. By examining the TCP/IP packet structure, we gain insights into how the Internet handles large volumes of traffic with varying service quality requirements. Exploring advanced TCP/IP features and their applications. Advanced features of TCP/IP, such as quality of service, QoS, security protocols like IPsec, and the use of virtual private networks, VPNs, represent the protocol suite's evolution to meet modern networking demands. QoS mechanisms prioritize traffic to ensure that time-sensitive data, like voice and video, are transmitted efficiently. IPsec enhances security by authenticating and encrypting IP packets, thereby enabling secure, encrypted communication over potentially insecure networks. VPNs utilize TCP/IP protocols to create secure tunnels across the public Internet, extending a private network across a public network. This allows users to send and receive data as if their devices were directly connected to the private network, ensuring secure access to network resources. These advanced TCP/IP features are essential in a world where reliable and secure communication is paramount. Decoding the structure of Ethernet frames. Ethernet frames are the fundamental units of data transmission within a local area network, LAN. An Ethernet frame begins with a preamble and a start frame delimiter, followed by destination and source MAC addresses, which are crucial for directing the frame to the correct recipient. The type/length field indicates the nature of the payload, which is the data encapsulated within the frame. The payload is followed by a frame check sequence, FCS, a form of error checking that allows the receiver to detect if the frame has been corrupted during transmission. Understanding the structure of Ethernet frames is key to comprehending how data is formatted and reliably transmitted over a network at the link layer. The role of network encapsulation in data transmission. Network encapsulation is a fundamental concept in TCP/IP networking, involving the wrapping of data with protocol information at each layer of the TCP/IP model. Each layer adds its own header, and sometimes a footer, to the data from the upper layer. This process allows for modular data handling, where each layer performs its designated role without concerning itself with the specifics of other layers. For instance, when a data packet moves from the network layer to the transport layer, an IP header is encapsulated by a TCP or UDP header, depending on the protocol. This encapsulation process ensures that each part of the network can independently manage its own operations, leading to a more robust and efficient system. It's this layered approach that allows for the seamless integration and interoperability of countless networks that make up the global Internet.